Okay, we're going to look at arcs and chords for a little bit. Let's suppose you've got a circle, and of course you've got the center point here, P, and there is an arc out here. You've got a little radius coming out, another radius coming out over here, and you've got this arc denoted this way, arc AB. Okay? Now, notice this angle over here, this angle right here, what we'll call the central angle, because it's made with the vertex is the central point of the circle. This central angle here is less than 180 degrees. Okay, so we call this arc a minor arc for that reason. Now, if you look at the other part of this arc over here, okay, the rest of the circle, and I'll say this is arc ACB. That arc is bigger than 180, so we'll call that the major arc. So we've got a minor arc and a major arc. Now, I want to talk about the measure of these arcs. First of all, the measure of AB. How are we going to talk about that? Well, let's suppose that this central angle is 60 degrees, just for sake of argument. Then we talk about the measure of AB, written this way, as being 60 degrees. Okay? Now, the other arc, the bigger arc, well, it's the rest. We've got ACB. That's going to be 360. In other words, there are 360 degrees in a circle, minus the arc that is taken up by AB. So this is 300 degrees. So we say the measure of arc ACB is 300 degrees. So we've got these major and minor arcs. Now, so let's just practice that a minute. Here we've got a circle, and we're assuming here that NP is the diameter. Notice that the measure of MN is going to be 80. Okay, now the rest looks like MPN. MPN, that's the rest of it. All of that over there, that's going to be the measure of MPN is going to be 360 minus 80. Okay? Yeah, which would be 280. Okay? Now, let's look at PMN. Okay, we'll look at that one. PMN. Erase what we've got here. Okay, so PMN, this part right here. Well, this is a semicircle, so it's going to be 180 degrees. The measure of PMN, that's a semicircle, so it'll be 180. Okay, so that's how we talk about the measure. Okay, now we of course we can add the arc length. So the arc length addition postulate. Well, let's just see how this would work. Let's suppose we want to find the measure of GE. Well, what we're going to do is we're going to add this arc length, which is 40 degrees, and we add that to this arc length, which is 80, and we get 120 degrees. Okay. See, so that's just practice doing this arc addition postulate. Now let's look at GEF. So GEF, well, that's going to be just like the others. We're going to add 40 to 80, but now we add 110 to it. So we've got 120 plus 110, and that's going to be 230. So we've got 230 degrees. Okay, that's the measure of that arc. GF, let's see here. GF is going to be this. Okay, so that's going to be 360 degrees minus 230. In other words, they're only 360 degrees in a circle, and GF is what is left. So this is going to be 130 degrees. Yeah. Okay. Now, so we want to talk about, so we know what we mean by the measure of an arc, but what do we mean by the measure, what do we mean when we say two arcs are congruent? Well, let's investigate a little bit. You can see here we've got a circle and we've got arc AB is the same measure as arc DC. They're both 45 degrees. And notice they're from the same circle. So we say, yeah, obviously those two arcs are congruent. Now notice we've got part B. We've got circles that are congruent, and notice that the measure of PQ is equal to the measure of RS. They both are equal to 80 degrees, so we would say, okay, PQ is congruent to RS because they're not from the same circle, but they are from congruent circles. But now, look at this over here, part C. Notice that the measure of XY is equal to 65, and the measure of ZW is also 65 because we have concentric circles there. But obviously those arcs aren't congruent. So you have the same measure of the arc, but we're not going to say those arcs are congruent. They either have to be from the same circle or congruent circles. Okay, now let's look at some theorems here. In the same circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay? So look at this. I've got an example here. Notice we've got this chord and that chord are congruent. Therefore, the arcs are congruent. So in other words, that means that 2x is equal to x plus 40. Okay? That means that x equals 40. Okay? So that's how we would use that. We notice, congruent chords. Therefore, this must equal this. Okay, now let's look over here. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. That's a cool thing to know. Okay? Okay. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay? Now, let's look here. Next one. If one chord of a perpendicular bisector of another chord, if one chord is a perpendicular bisector of another chord, then the first chord is the diameter. Okay? So notice we have this thing right here. This chord bisects this chord perpendicularly. Then we know that JK is the diameter. Okay? Now going down here, 10.7. So these are just some things, some properties of circles and their chords that we're taking note of. In one circle or in congruent circles, two chords are congruent. If and only if, remember it goes both ways, they are equal distant from the center. So look, these two chords, this chord and this chord are congruent if these, okay, if they're equal distant, okay. Now it goes both ways. If those chords are equal distance from the center, then it means they're congruent. So it goes both ways. So let's take a gander at how we might use that. Let's suppose we want, in this mess over here, we want to find CF. Now we know that AB is equal to 8. Okay, so we know AB is equal to 8, and we also know that DE is equal to 8. Right away, when we know that, then we know immediately that those chords are equal distance from the center. Okay? Yeah, now, so let's see what we have here. We have this perpendicular bisector here. So that means this is 4 and this is 4. You know, this is 4 and this is 4. Okay? Because we've got this perpendicular bisector. Okay? And what I want to do is I want to find out what CF is. Well, I know that the radius is 5 here. And look, I've got a right triangle here. See? Dig this right triangle. And in fact, it's a 3, 4, 5 right triangle. So I know that CG is equal to 3. Now, you could use Pythagorean theorem as well, but it's equal to 3. Therefore, CF is also equal to 3 because it's the equal distance. Yeah, so what we need is just a little practice using these ideas.